Welcome to part 2 of our chemistry lecture series. In this video, we'll be going over chemical bonds. Chemical bonds hold atoms together within a molecule or attract one molecule to another. The most important types of chemical bonds are ionic bonds, covalent bonds, and hydrogen bonds. So bonds are formed using the electrons in the outermost energy shell. In our last video, we said that there can be several energy shells for a different element. The ones in the outermost shell, we term those valence shell electrons. And following the octet rule, atoms interact in order to have 8 electrons in their valence shell. Or if they only have that first energy shell, it can hold up to 2. So let's look at some inert elements, elements that are not going to react. They don't want to have any more electrons or lose any. For example, helium. It only has that first energy shell, and so the first energy shell is full and content with 2 electrons. Neon, on the other hand, it has 8 valence electrons, 8 electrons in its outer shell. It does not want to gain or lose electrons. It is exactly happy the way that it is. Reactive elements, on the other hand, do not have their outer shells complete. For example, hydrogen, it only has 1, so it wants to gain another so that that outer shell is full. Carbon only has 4, so it would like to have 4 more. Oxygen only has 6. It wants to gain 2 more. And of course, sodium only has 1. So it'll take a lot of energy to gain 7 electrons. So sodium will be willing to give up its 1 so that the next shell becomes its outer shell and has a full 8. So chemical bonds, when we have a transfer of electron, where one atom loses an electron and the other gains, we call this an ionic bond. Versus when we have the sharing of electrons, we have a covalent bond. So focusing on an ionic bonds, we have attractions between anions and cations. Take a moment, if you can remember from our last video, and see if you can define what an anion is and what a cation is. Awesome. You should have said that an anion is an atom that gains an electron, and a cation is an atom that loses an electron. Electrons are donated from one atom to another when we form an ionic bond. For example, we have sodium here. It has 1 valence electron. It wants to have 8. And chlorine has 7. It also wants to have 8. So it is simple for sodium to transfer its electron over to chlorine, forming the chloride ion. Now we have a positive charge and a negative charge. Those two will attract and we form an ionic bond. Our next category, covalent bonds. We have different levels of covalent bonds. We can have a single covalent bond where one pair of electrons is being shared. For example, between 2 hydrogen atoms. One hydrogen atom has 1 electron and the other hydrogen atom has the other. They both want to have 2. So if they share those electrons, then they both have a full outer shell, 1 from each being contributed, traveling around both nuclei. We could also have a double covalent bond where 2 pairs of electrons are being shared. We know that oxygen has 6 valence electrons and it wants to have a total of 8. Carbon has a total of 4 and it wants to have a total of 8. So if it shares 2 electrons with one oxygen and 2 electrons with the other, its outer shell is happy at 8. And if the oxygen is sharing 2 pairs of electrons from the carbon, its outer shell is also 8. There are 2 different types of covalent bonds, nonpolar and polar. In nonpolar bonds, electrons are shared equally. This is the strongest type of bond. In polar bonds, electrons are shared unequally. They spend more time, in this example, near the oxygen than through the hydrogen. Let's look at polar molecules. Water, for example, is a polar molecule and it has an unequal sharing of electrons. The red oxygen here has 8 protons in its nucleus, 8 positive charges pulling on those electrons, versus the hydrogen has 1 proton in its nucleus. That is a weaker attraction. So those electrons that are shared are going to spend more time around the oxygen than they do around the hydrogen. Once we have a set of polar molecules, we can have what is called hydrogen bonding. These are weak intramolecular or intermolecular attractions between a slightly positive hydrogen and a slightly negative oxygen or nitrogen. So what is an example of intermolecular and intramolecular hydrogen bond? Well, let's look at the difference here when we're looking at hydrogen bonding in water. If we talk about intermolecular, That term inter means between two different things. If you were traveling internationally, you'd be traveling between two different countries. However, intra, for the intramolecular, that's within the same. If you've ever been to a school where they have multiple sports teams playing in a tournament from the same school, they call those intramurals within the same institution. So we have our hydrogen bonding between our slightly negative oxygen and our slightly positive hydrogen. That forms that weak bond. That is intermolecular, between two different water molecules. But intramolecular, within one water molecule, we see the polar covalent bond between the oxygen and the hydrogen. Hydrogen bonding is important in many areas, especially in DNA when we're looking at anatomy and physiology. If we look between the nucleotides that we'll learn about later in the semester, thymine, adenine, cytosine, and guanine, you'll see that each of them have dotted lines in between each other in the DNA structure. Between the A and the T, we have 2 hydrogen bonds, and between the G and the C, we have 3 hydrogen bonds. These are important because these weak attractions are easily broken apart, which will come in handy when we talk about protein synthesis. So this is the end of our chemical bond video. Please come back for part 3 for our chemistry lecture series. See you then.